We usually think of evolution as a relentless arms race, a process of constant adaptation just to stay alive. The ancient archosaurs, a group of reptiles living 230 million years ago, represent a massive fork in that evolutionary road. One branch of that ancient family tree became modern birds. To survive the millennia, they scrambled their genetics, fracturing into thousands of differing shapes, sizes, and species to adapt to shifting environments. This animated timeline shows the crocodilian branch. Because they mastered the amphibious ambush niche early, they faced little pressure to innovate. Their remarkably stable genome survived the asteroid impact, remaining the least changed reptile lineage, now commanding food chains across 91 countries. These animals did not stall out in the evolutionary race. They simply arrived at a highly lethal biological design so early that they never needed to upgrade it. The physical architecture of a crocodilian skull is built for total concealment. Their eyes, ears, and nostrils are packed tightly at the absolute top of their head. This allows an animal weighing up to a ton to submerge its entire body, breathing and scanning the surface without breaking the waterline. Even if they can't see their target, they can feel it. Their skin is covered in tiny, specialized bumps called sensory domes. If a single drop of water hits a dark pool or a fish twitches nearby, these domes register the exact location of the disturbance. Look at this diagram showing a cross-section of a crocodilian head. Because they hunt in aquatic environments, they need a way to open their mouths underwater without drowning. A specialized flap of tissue at the back of the tongue, called a palatal valve, locks their throat firmly shut. When the jaw snaps shut on a target, that valve holds tight, keeping their internal organs perfectly dry during the ambush. These integrated systems allow a one-ton predator to occupy the same space as its prey, while remaining entirely undetected. That precision hunting is backed up by fierce energy conservation. As cold-blooded ectotherms, crocodilians rely entirely on the sun to warm their bodies. They do not waste precious calories generating their own internal heat. This schematic reveals how they use that saved energy for buoyancy control. By flexing abdominal muscles, they pull their lungs backward inside their torso. This drops their center of gravity, allowing them to sink silently. If the environment turns hostile during severe droughts, their biology enters an extreme low-power state. They dig burrows in the mud and drop their heart rate from a standard 40 beats per minute down to just 5. Because their metabolism plummets, a fully grown adult can survive for an entire year without consuming a single meal. When global ecosystems collapsed millions of years ago, warm-blooded dinosaurs quickly starved. The crocodilian's ability to essentially turn its bodily functions off allowed them to weather the apocalypse. When they are active, their offensive hardware is unmatched. They boast a robust immune system that wards off infections in stagnant swamps, possess the strongest recorded bite force in the animal kingdom, and easily cycle through up to 3,000 replacement teeth in a single lifetime. While the underlying machinery is identical, regional species have developed subtle exterior variations. You can identify an American alligator by its wide, U-shaped snout and an overbite that neatly hides its lower teeth when the mouth is shut. Compare that generalized tool to the gharial up India and Nepal. It sports a remarkably thin, needle-like snout, engineered to slice through water and catch fish, topped with a large bulbous growth used for mating calls. The 27 species patrolling our waterways today represent minor, localized hardware tweaks made to an already perfected biological chassis. For all their armor and crushing power, their behavior displays a surprising complexity. They are the only reptiles on Earth known to possess a strong maternal instinct. After laying her eggs in a carefully constructed nest, the mother acts as an aggressive sentinel. Once they hatch, she will fiercely guard her tiny young for up to a year, keeping them safe while they learn to hunt small crustaceans, sitting safely against the crushing jaws of their protector. This extended care is a strict ecological necessity. Because they grow so slowly, the hatchlings are exceptionally vulnerable to birds, snakes, and wild pigs. Ultimately, only about 1% of crocodilian babies ever survive to adulthood. This creates a high-stakes ecological cycle. A creature that grows into an invulnerable, armored tank begins its life in a state of extreme fragility, where a single year determines the survival of an entire generation. That balance was shattered in the 20th century. human commercial hunting aggressively targeted their skin, specifically the thick, bony plates called scutes and osteoderms, pushing animals like the American alligator to the edge of extinction by the 1970s. Removing them caused immediate downstream collapse. As natural scavengers and apex predators, crocodilians dispose of rotting carcasses and regulate local fish populations. Without them, waterways quickly stagnated and food webs broke down. Fortunately, their resilient biology makes them highly receptive to conservation. Once sweeping legal protections were put in place and the commercial skin trade declined, the American alligator rapidly bounced back, multiplying to a stable population of over 5 million today. Crocodilians represent a design so refined it has outlasted the need for further change. Their presence in our rivers today is the result of a biological blueprint built to endure for hundreds of millions of years.